Good morning, everyone, and welcome. So, you finally made to Code Talks 2023. Very welcome to the first session of Code Talks 2023 in Cinema 8. Remember that. So, my name is Aarik, and it was mentioned just a few seconds ago. I'm engineering domain owner at Metro Digital. What does I do? As engineering domain owner, I'm responsible for two separate domains or business entities known as web and customer master data for the entire global services. So, what is Metro Digital? As you might have heard the name Metro Cash and Carry, it's a German-based organization for B2B wholesale retail industry. And Metro Digital provides all the technical engineering landscape for all end-to-end processes and platforms for our cash and carry business. And that's why engineering domain owner. I'm really into engineering, and as you're thinking, right now we are in GCP, DDoS. Now, I'm going throughout the session, I'm going to ask questions where maybe I will ask you to raise hand to see how many of you are actually familiar with terminologies and so on, so I can decide where I can skip a definition and where I can add it. Is that okay with everybody? Yes or no? Sounds perfect. So, by the way, I always had my sessions in the second half of the day. What happened was most of the people who come, they're always sleepy and tired, with all the nachos and cokes. But guess what? I'm in the 10 a.m. in the morning. So I have a really little surprise for you. We have to cover 48 slides in 45 minutes, guys. So I need your full support. Yeah, I'm just kidding. There are a little bit more animations in the middle. So directly jumping into it. How many of you really know what actually DDoS is? Just knowing. Wow, looks like the full house is about awareness. Now I'm going to be asking one other question. Are you planning to defend a DDoS attack or perform a DDoS attack? Okay, because you guess what? You will learn both of them in this session. Yeah. So in a nutshell, I just stole one picture from Wikipedia. I have somewhere commons.wikimedia.org. So these are the abbreviations we are going to use. So there is an attacker, and then we have a controller server which creates a lot of zombie instances all across the world. And then all those zombie instances send requests to a specific source to overwhelm their, let's say, CPU, memory, network bandwidth, and so on. And there are different categories of DDoS attack. How many of you know there are different types of DDoS attack, and which are those? Just scream the attack. Okay. So I think the question was not clear. So there is, first of all, HTTP flooding. Then you have a TCP SYN flooding, and then there are different transport and infrastructure level, network level flooding as well. There are different tools that are used for different purposes. For example, there is a GitHub open source library for MKR that is used for HTTP flooding, which is for, let's say, load testing and so on. Similar to Apache Bench, which we are going to use today. And then there is HPing3, which is used for SYN flooding. So in case you always are going to work on the defensive side, please get to know how to also perform it, because you are not going to wait for real attackers to do it and validate if everything is working. That's why we will have a little bit of demo about it as well on a live application. So moving forward, in general, whenever you want to establish a smart system, not just one layer, because in more 10 years ago in historical implementation, there used to be a basic term called rate limiting. Okay, you allow these many requests in these many seconds, and after that, block everything else. But the modern attack synologies also evolved, because they are now have web scrapers and crawlers that actually detect what is your rate limiting threshold. They do it over the period of time, and then when they know exactly where your rate limiting kicks off and so on, they scale their attack accordingly. And we know this because in Metro, we have 154 global websites available, and we are pretty much under DDoS attack all the time. Even on our shop website and our main primary landing pages, it's pretty much every second day. The largest DDoS attack we ever faced was basically 20 million requests per minute. That was the scale. That's quite high with HTTP flooding. And we saw it, they were out of 10,000 different unique IPs from 174 countries. How many of you know how many total countries are there in the world? Yeah, it was a very weird question, trick question, right? Nobody would expect this. It's 195. I think there are one or two countries either going down or coming up, like our infrastructure. So sometimes 194, 3 years later it's 196. Yeah. Moving forward, we are going to go into GCP. How many of you are aware or hands-on on GCP, not just aware? Okay, so there are people who are aware of GCP, but not worked on hands-on. Perfect. Then we are going to go through certain platforms and products and services in GCP that we are going to use. First one, and we are only going to talk about architecture. After that, we directly jump into a small demo, then you will test it, and then we will validate stuff. Kubernetes engine. How many of you know what Kubernetes is? Ah, yes, I can skip this one. Perfect. Then with you deploy a specific app in Kubernetes engine, and I have done that for you to show you. And you can also take away something from this later on. Then I've pretty much used GCE Ingress Controller, which is Google Cloud platforms itself native ingress controller used in Kubernetes engine to basically provision the load balancing and all the other resources, because you want somehow everything to be automated, right? So nobody wants to do it manually using Terraform. I'm using GCE Ingress Controller. There is a small limitation I want to share. If you're going to use any other ingress controller like Nginx and so on, some of the feature set of GCP platform, especially in this architecture, might not be compatible. And I'm going to share which features are not compatible with Nginx controller, and they have missing annotations, and it's still in development. Then, of course, connect the load balancer to the app. Then this is one of the most and the first learning that we ever had. 2.5 years ago, during COVID time, we actually got our, let's say, second largest DDoS attack. It was 10 million requests per minute. And our infrastructure is auto-scalable, vertically, horizontally, and it's quite broad and extensive. But still, we were down for hours. What we didn't do, which we should have done beforehand, was have a CDN layer, which basically helps you to mitigate heavy lifting from your backend server to basically distributed one, which is a cloud provider provides. So for example, Google Cloud had its own CDN, you have Cloudflare CDN, you have every platform has their own CDN. We did not have this, and each and every request was practically taking 2.3 megabytes of download from our backend, and each 75 different unique calls. So there were 75 threads that need to fetch resources from backend for one single page click. Someone did www.metro.de, enter. That much stuff was happening for the server side. And now we are gone into completely different world. This was the first evolution that we did. Everything moved to Cloud CDN. Everything, each and every static and dynamic resource comes from Cloud CDN. There is a presentation layer that takes care of it. The only one request goes to server is to fetch the document. That's how optimized our web applications are these days. So if you open www.metro.de or macro.nl, any of the Metro Cache and Carry website, each one of them have one single request to the backend server. Once the document is fetched on the browser, everything else comes from Cloud CDN, each and everything. So that really saves a lot of it. Gives your infrastructure, your server, your, let's say, infrastructure, everything else, lot of CPU and memory bandwidth to basically deal with all those requests that are coming. And these days, we have really powerful infrastructure, especially to deal with these resources like requests and so on, like multi-threading, you have hyper-threading and so on. Then Cloud Armor. How many of you know what Cloud Armor is? Okay, I think these are half of the people who raised hand for GCP. So Cloud Armor is the WAF for Google Cloud Platform. So it's a web application firewall that you can integrate. You can integrate with external load balancer with Google Cloud. There is also a limitation. Cloud Armor will only attach to a classical external HTTP load balancer. So if you try to use the advanced load balancer, there are two different versions. External, Cloud Armor is not compatible. And it's also not compatible for any internal network load balancer. So this is one of the limitations. So this is basically for your end customer facing applications. If you have your internal intranet application within your VPCs and Google Cloud and so on, they will not have Google Cloud Armor as of now. For those, they have identity aware proxies in Google Cloud, and maybe you should check those. Then we are going to go for reCAPTCHA. How many of you have successfully passed a reCAPTCHA? Ever in any of the websites? Just to verify if your bots are humans, because we are going to verify this as well. And how many of you failed it? I'm glad I'm not the only one. So in general, in nutshell, you can take a picture of it right now. I'm just kidding. You can get the slides later on. So this is the only architecture that you require. And I have deployed a very, very small application to basically show you how it's done and what are the key factors of WAF. And can you see my mouse? Oh, you can, but it's black. I hate Mac for this. So Cloud Armor and reCAPTCHA, we are going to jump into these and see what are the feature sets of these WAF that differentiate these from other WAFs. And they're really cheap. That's one of the other part. So I'm going to go out of the presentation. Can you see it? Perfect. So we are going to go for the first part. every WAF product like Akamai, Azure, what was the name of that? I've always forgot. There is some Azure one we were using a lot time ago. Their WAF also have pre-configured rules. Cloudflare, oh, sorry, Amazon also have it, and Google Cloud also have it. One of the most crucial part is that Google Cloud actually keeps it very, very updated. So for example, if there is CRS 3.3, 3.3.5, so there are even subversions or minor updates coming on for OWASP policies and so on, Google Cloud really very fast implement these in their native batch. What it does is you get the capability of having these rule sets directly defined from the OWASP definitions. So you don't have to write regular expressions to figure out which request should be blocked for SQLi, which request should be blocked for RC, remote code injection, for example, remote code execution. You basically can just use one single says pre-configured WAF rule, bracket quotes, and use the pack that you want to use and apply, and then it's going there. Then there are additional layers on top of it. You also get the threshold or sensitivity on these WAF policies, because you might have played with OWASP policies in any of the platform and so on. If you go with the default package, it never works. Pretty much your even internal application calls are showing it's SQLi, it's RC, it's this and that. Have you ever noticed this? Anyone? No? One person. Wow. I think we are the only guys playing with OWASP, I guess. So this is basically where the heavy lifting will come for fine tuning, because in Cloud Armor, it's not about, hey, it's a plug and play tool. It's actually about creating something from scratch, customizing it for your application, and then after that, have a low maintenance and cheap price. That's basically this layer. And this is the most important part where you need to really spend time. And I spent practically 3 months for the first application to have these OWASP policies figured out. Because our REST APIs and our other SOAP APIs and so on that were working within our application from external endpoints, they were considered or flagged as one of these vulnerabilities. OWASP, they were voiding the OWASP policies, and those requests were getting blocked. So you have to go for sensitivity, but you also have to see which ones should include, which one not. Then there is one more part, which is basically not that you can get the entire package, you have sub packages. So for example, let's take a look at SQLi. So there is the main package that is called basically this, SQLi stable or canary, that will apply everything, and you can have sensitivity highest. But you can also select specific OWASP policies, but you will not select individual out of this. What you would do is you will take the whole pack and exclude those that you don't want while doing a proper testing with your live application. The good thing is you can have a preview mode in GCP, so you do not have to, even on production, you can have a testing. So you can enable these rules on preview. In the log, you can see which request actually would have been blocked by which rule. And then you can fine tune basically. Then you also have sensitivity level. So basically, this is how you exclude. These are the policies that are excluded. And this is basically the pack. And then there is somewhere the threshold. I'm going to there. And then there is a specific property where you can add sensitivity as well. 4 means the highest, if I'm not wrong. And 1, 2, 3, 4. And this way, you actually have a lot of pre-configured rules that you can use out of the box. But that doesn't cover everything. That's where threat intelligence comes. What it does is Google already have a huge infrastructure for global internet. I'm pretty sure there is high 2-figure % of internet every single day goes through Google network. So what they have is really a lot of data, and they also have flags. This is vulnerable, this is suspicious, this is spam, this is that. And we should be able to use it and utilize it. So in Google Cloud Platform with WAF, this threat intelligence comes, which was released practically 1 year ago, and they are working actively on these, having more and more rule sets. So for example, Tor. How many of you know what Tor is? Okay, you are the good bunch. I'm not sure if you are in defense or offense, but good to know, good to have you here. So Tor basically was an open source network created by US Defense, if I'm not sure, US Navy or Army, Navy or Air Force, something like that. And then it was open source to basically provide anonymous networking for global. Of course, once you put anonymous, and it's really anonymous, quite accurately, then this is going to be used by malicious people. So there are people who are misusing it. So majority of the Tor exit node. What Tor exit node is? Have you seen a spider web? So for those who are not aware, basically every single interaction where a single thread is joining to other is a node within the network of Tor. It basically replicates the same. But then all the threads, or what is it called, silk, I don't know how to call it, spider web, is attaching to the walls, suspending the web. Those are the entry and exit points for real internet, and that's called exit node. And that's the only vulnerability of Tor, that if your information is somehow stored on those Tor exit nodes, then it can be tracked back to you, because everything else from there is basically completely with your ISP, with your internet provider, and so on. Unless you're stealing the internet, then you can be covered. But then you have MAC address and so on. So it's a very long journey. Maybe Edward Snowden can help you with that. So Tor exit nodes are really doing it. And for our 10,000 different IPs, 6,700 something IPs were Tor exit nodes. So why should we allow any traffic from there? Because as of this moment in 2023, not I think the real customer base in Tor network would be 0.0001%. And we are B2B wholesale retailers. I'm pretty sure we don't have a restaurant or catering or five-star hotel owner who is going on Tor browser to browse web, because it's really slow, it has ridiculous experience. So by default, checking the customer persona, seeing the use case, we said we're going to block every Tor IP. So if you request anything towards Tor, it will be blocked. And that's how simple it is. Create, evaluate threat intelligence, use the Tor. Then you have known malicious IPs. So all the IPs that were flagged by Google for doing malicious stuff like sending too many requests in too less of time and so on, you basically can have those on your usage. This one is a scary one, where if you have end customer application, please be aware your customers might also be flagged as malicious. I mean, I have a static IP from my ISP, and I'm pretty much ducked in that category because Google has marked it malicious. I can't go open any page without a reCAPTCHA. So I have to use VPN now. So I was doing too much of testing and hit and trial error, and now my IP is marked as malicious. And this can happen to real customers, and you do not want to influence it. So there is a silver lining if you want to use it or not. We are not using it for that matter. Search engine crawlers is basically if you want to whitelist, block, rate limit, and so on. Cloudflare, Fastly, all the other platforms. This is the second layer of configuration that I would propose involve. Then the third is basically called adaptive protection suggestions. Cloud Armor comes with two different modes. Standard mode, which is quite cheap, and then there is an enterprise managed protection plus mode. And in this managed protection plus, you have this machine learning algorithm in the background that keeps learning your traffic. And based on your traffic, it every single time very accurately can predict a real DDoS. And what it is capable of is if your rule set somehow allow really huge or X number of requests backend to your backend, then it can suggest a rule to you. And then you can review it and you can deploy it. We have done it a lot of times. I'm going to show you the demo rule as well. It didn't work that well, but just to share. And then adaptive protection suggestion rules automatic deploy basically is if you are at the weekend somewhere in Greece, and basically you are one of the rare people who have access to this, and there is a DDoS attack, right? So it would be very hard for you to even go log in and approve that stuff. And having a webhook based interface to do this, it's just too much of over engineering in my opinion. So this automatic deploy comes in handy. What it does is it says you define your entire WAF rule sets, and then based on top of that, if there is a DDoS and you get requested in your backend, we are going to deploy one additional rule on top of everything, which will be on higher priority. So you can have either another layer of throttling. So maybe your initial throttling limit is only allow 60 requests per 60 seconds. And after that, if somebody sends 100 requests in a minute, only the first 60 goes to your backend, gets a response, the rest 40 are blocked. Maybe this is your default throttling. But if there is a DDoS and there is a 10,000 IPs, so basically there are 600,000 requests that are coming every single second to your backend source, then you can have another throttling layer deployed, which says allow 20 requests per minute. And that will kick off only for the duration of DDoS attack. There is a configuration here where you can select what is the duration that you want this policy to be applicable for, what is the percentage threshold, which means in Google Cloud Armor, since it's machine learning based algorithm in the backend, it actually can predict what is your real traffic baseline that might get impacted in case you block this or apply this rule. So you actually get the choice, okay, 20% of your customers might lose access to your website, but because you are completely down for 3 hours, it does make sense to give other 80% your website. So you actually have to see from business point of view what actually makes more sense. Then there's a confidence threshold. Then you have a load threshold, which basically is the sensitivity of the entire adaptive protection rule. So how much of the bandwidth should be occupied before this rule is applied. So I have this in rule, so I'm going to share it. Apart from these are the packs that come with the WoF with Cloud Armor, but then there is default rule sets. So the old native 20, 30 years ago, we had rate-based ban, throttling, and allow. So basically, throttling is only allowing X number of requests in Y amount of seconds. And after that, anything that exceeds will basically be denied. And then when the clock resets, you are allowed again. Then rate-based ban is basically where you specifically have a specific throttling, like, okay, allow 66 requests in 60 seconds. Do it for 1 minute, then observe the next minute. If it happens again, you block this user for, let's say, 5 minutes or something. So you basically can give a user a chance on top of throttling to basically either still continue getting responses, or you actually block him. And then there is redirect, and there is two different redirects. One is just showing a 3 or 2 response. This is 3 or 2 redirected, where to your any landing page, HTTP page in your bucket, and so on, storage bucket. Even some other website will also work. Then there is Google reCAPTCHA. And Google reCAPTCHA is really nice because when you're large scale organization, you actually can afford it, because a reCAPTCHA Enterprise is quite expensive for validations. So if you can get with reCAPTCHA Enterprise, you will get the capabilities to have integration of reCAPTCHA with WoF. And it has a very good interaction, because the first request does not come to your load balancer at all. Directly on network layer, Google Cloud basically redirect the request to reCAPTCHA, says, hey, could you please verify if this person who is trying to open this domain is a person or bot, and give me a specific number, which is between 0 to 1. 0 means it's a bot, 1 means it's a human. And then you can set the threshold like, hey, okay, if there is 0.7 above, which is a human, I'm going to let the person see the website. Below that, you show him something else, or let him pass some reCAPTCHAs, difficult ones, and so on. So this is natively supported. It's on network layer in Google Cloud, which means you load balance and does not get the request until reCAPTCHA is completely validated. Why it's important? Because normal DDoS, when you talk about SYN flooding or HTTP flooding, they're not smart. They are just botnet attacks. They are only sending requests. There is no layer, smart layer, to solve these reCAPTCHAs and so on. Even though there are bots available right now that can solve reCAPTCHAs, really advanced ones, they cannot be used on the scale of, let's say, sending 15 million requests per minute or so on. So that's where the silver lining is. For this reCAPTCHA implementation, you get the first part, which is you do not get flat DDoS. You will be secured from botnet attacks. All the requests will go to redirect reCAPTCHA. reCAPTCHA will fail, of course, because it's not a real browser. It comes from a terminal or shell or something, and then your website or load balancer does not even receive a single request. That's the one layer. Second, you have reCAPTCHA Enterprise, where you can have validation of tokens on your server side, where you can say, hey, I want to validate this, if this person is really doing something legitimate or not. That's where the smart bots also are not able to pass, because you are giving them reCAPTCHA ad hoc. So they pass the first one, but then randomly they get a reCAPTCHA. For that, they have two different setups. So there is a reCAPTCHA challenge page, as I can show you here, and it says WoF service CA, which is called Cloud Armor. Not sure, can you see it? Can everyone in the end see it? Okay, perfect. Thank you. And then you have this session one, reCAPTCHA session. What it does is, after the first initial challenge page happens, after that, it creates a session cookie, gives a score to that user. But then when the user moves his mouse and clicks and does something, sends requests, refresh the page, based on behavioral patterns, Google keeps updating the score. And then we as application owners can define, okay, if the score at any point of time during the session drops between 0.5, for example, I want this person to prove again that he is a human, not bot. This is basically to save real smart reCAPTCHA attacks, where there are bots, small scale bots, that are able to bypass your reCAPTCHA and submit some post request and have some submission of forms and so on. And this is the second layer for those. So every time this happens from the specific session, Google reCAPTCHA will automatically redirect the same session to reCAPTCHA. Then there are three levels of reCAPTCHA. One is just a JavaScript challenge that does a mathematical equation that you might have seen. The smart reCAPTCHA is called in native language. The second one is the checkbox, where the tick box is, like very simplified one. And the third is the image one with fire hydrant, trucks, and bikes, right? These are the favorite. And there also you have different levels, easy, medium, and hard. Sometimes it's so easy that you select 1, 2, 500 and your website is open. Sometimes it's 3, 4, 5 different pages. So reCAPTCHA with integration of Cloud Armor and Google native networking layer, this basically provides this entire experience. Now I'm going to show you the holy grail, the rule sets that I recommend in that set for everybody. Ready? There we go. I'm not sure if it's visible. So this is a demo application that I have for you guys. As you can see, step by step. First, the threat intelligence. I want all Tor exit nodes to be blocked by default. And of course, it's just my testing application. I do not want Google to rank it the best application in the world for 2023. So I have to block search engine crawlers. Then known malicious IPs. Well, I'm testing, so I do not care. I want everything blocked. And here you can see I'm using all the basically pre-configured rules like XSS cross-site scripting. Then there is LFI, which I don't know, RFI, I'm not sure, RC, remote code injection, SQLi, and then sensitivity for hardest. And then you would have these OWASP policies that I have to specifically whitelist even for a static HTML application. I have a static application, and I'm going to show you, even for that, I had to exclude this because every GET request shows that, hey, you are voiding this policy and your request is blocked. So this is where you will spend majority of the time. Arriving here is really fast, drafting a first rule. You know your traffic baseline, you know your customers. You'll think, hey, you know what? We are good to go, roll it out. That's fine. But honestly, there are really smart and easy ways to figure out what exactly these rule sets on application are without seeing any of your backend. You have really smart crawlers these days where you can custom define a script, and during the night you can sneak around certain requests and see how many have get proper response, how many not, and voila, within 2 weeks, any attack can be custom prepared for your application. Then there is this evaluate adaptive protection. As I mentioned, here I'm doing reCAPTCHA, which means at any point of time, a session that is validated for reCAPTCHA session can be taken over. So if somebody stole a session cookie, they still get the access to CAPTCHA, can scale up a botnet, right? That's exactly why I added this redirect on the highest priority, that in case there is a DDoS attack, because I'm using Managed Protection Plus, I want this reCAPTCHA to be applied to everything, no matter what. And this reCAPTCHA will again be based on reputation of the source. Most probably it will not be just a mathematical challenge, it will be a checkbox or images one. This I've trial and tested and it works. And then there is this layer which is looks complicated, but it's not. Basically, what it is send all the requests first to reCAPTCHA, which gets a cookie, stores it, and then after that, that session do not execute this particular rule set, which is 2 million. And afterwards, then you validate if the reCAPTCHA session is valid, and then you validate also the score, that score I was talking about, because the score is encrypted on the session, and every request is having this session in the on the network layer directly on Cloud Armor side. So you can validate that the session score is more than 8 and 7 and 6. Then this is basically, once the redirect happens, basically these two are to do showing it again. Once the redirect happens and the reCAPTCHA is valid, you are proved to be human, then you face the second level of test, which is you are still allowed only X number of requests in Y amount of time. Otherwise, you get a ban. So this is how these rules are set to basically have a foolproof solution where there is no spectrum, at least that I could not figure out at any point of time, that there is a set of requests, there is a set of attack pattern that could not be defended by this. And this is basically also derived from what attacks we received. We actually analyzed all the data, and based on all that data, we custom tailored this. But this is only for reference. Then, of course, I was mentioning about showing you this adaptive protection. First, let's go through these modes. This is the standard one. There's Managed Protection Plus. For Managed Protection Plus, it's not that expensive because you have to pay 3,000 euros for the whole organization. And then you get to defend 50 backend load balancers with those 3,000. After that, each load balancer is 50 euros per month more. That's the only. So basically, for Cloud Armor, with enterprise features and this machine learning, auto deploy, and so on, all these WoF threat intelligence, you pretty much pay 50 euros per month per load balancer. So that's where this is basically coming as compared to Akamai and Azure, very far away in terms of efficiency. But the problem is in Akamai and Azure, you have plug and play available. And there are people, they provide professional services for you. This is hardcore for developer and engineers. That's pretty much it. I'm going to take you to this. Could you please scan your mobile phones? Oh, sorry, scan this QR code with your mobile phones. Please do not connect to Wi-Fi, disconnect Wi-Fi and do it with your mobile internet. So it opens, doesn't work. It works, right? So what did you see? Rickroll. Sorry, guys, I had to do it before 10:30 today. This Rickroll, at least to a larger audience. So thank you for being the guinea pigs for Rickrolling. But basically, this is the application with just static GIF with reCAPTCHA session integrated with WAF and the architecture that I shared with you. Then right now, I can just perform a DDoS attack, and I will do it. Keep on running it for next 30 minutes. So I'm going to send approximately 10,000 requests per second towards this source IP, and you guys can open and play around with it and see if the application ever goes down. 99% it shouldn't go down. By the way, we can also play around after the session right outside on the Metro Digital booth. I will be available there just outside Cinema 8, and then we can play around more, and you can learn about how to do more DDoS attacks and so on as well. Then I would also like to share something for you to take away. This is artifacts that will help you to create all the infrastructure via Terraform. So this is a GitHub repository, open source repository that I created for you to deploy the entire architecture I shared, this one, in simplified manner. Of course, there are certain rule sets that are not available in Terraform package in Cloud Armor. So those are need to be fine-tuned, but most of it is completely integrated. So sorry for that. There is and I think this presentation will be available on the website as well. So at some point, you can also take it from there. Now, since I've taken 32 minutes of your time and I have rickrolled you successfully, I'm open for questions.